Okay, so good morning to all of you. Today we are discussing one previous year problem regarding refraction concept. So what is the problem today? Today's problem I'm discussing about lateral shift. What do you mean by lateral shift? Okay, so here I am considering one glass slab. What do you mean by the glass slab? For example, this is made up of glass. This is a glass slab. This will be like this. It is just like a box type, but it is made up of glass. Now, if this is a glass, when light ray comes and falls on the glass slab, what happens? That is the concept here. So this is actually three-dimensional figure, but it cannot be shown on the board, which is a two-dimensional here. So let me discuss about this problem here. So before discussing about this problem, I have to discuss about a concept of what is called as lateral shift. So for that, you try to understand here. This is a side view of a glass slab. What is the meaning of this? So I am drawing only this much part because the back part is unable to be, we are unable to see the back part. I am drawing only this much part, which is the topmost view of the glass slab. So in this glass slab, if you observe the glass slab side view, the thickness of the glass slab is considered to be T here. And when the light ray enters into the glass slab, it deviates. It bends towards the normal because the medium you are going to consider here is air and the medium you are going to consider here is glass. So when a light ray enters from air to glass, it bends towards the normal. And when light ray enters from denser to rarer medium, it bends away from the normal, as this is going to be the normal N2 here and this is going to be normal N1. So what is going to happen here? So the light ray, when it enters from rarer to denser medium, suddenly speed of the light reduces and it is going to tilt. You might have experienced that when you are going in a bike on the road, suddenly if sand is seen by you, if you are unable to control your bike, when you enter into the sand, definitely your bike is going to get tilted. Sometimes it gets skid also because of sudden decrease in the velocity. The same thing happens here also. When light ray enters from rarer to denser medium, it bends towards the normal because of sudden decrease in the speed. When it enters from denser to rarer medium, sudden rise in the speed of light ray takes place, because of which light speed catches up again the previous speed it will get. It bends away from the normal. So what is going to happen here? This is angle of incidence, this is angle of refraction. Light ray enters and bends and comes out. So what is an actual path? The light ray has to go in this direction, but as there is sudden deviation in the light ray, it is going in some other path because of this glass slab. And this is an actual path, this is a deviated path. So how much it is going to deviate from an actual path is called as lateral shift. So this x is considered as lateral shift. And I have to find out what is this lateral shift now. It's very simple to find out the lateral shift. So and the first thing here you have to do is, you have to consider here sine I minus r. So sine I minus r, if you consider, it is going to be opposite side BC and hypotenuse AB. So it is opposite side BC and hypotenuse AB, that is in triangle. In triangle ABC, which is a right angled triangle. Okay. So this is a rat. This is a right angled triangle because this is making 90 degrees and AB is going to be hypotenuse here. So let us see what is going to happen here. So sine I minus r is equal to opposite side by hypotenuse. And opposite side can be replaced, that is BC can be replaced with x, which is called as lateral shift according to a problem. So you have to see that lateral shift is this one, that is x by AB. So you can write lateral shift x is equal to AB sine I minus r. So now the next part is cos r. If you consider cos r, you know cos r is nothing but adjacent side, and this adjacent side you can consider as AD. So this is adjacent side AD and hypotenuse going to be AB. So this is adjacent side, that is going to be hypotenuse. And you all know I can replace AD with T. And what is this T? T is nothing but the thickness of the glass slab. So this is going to be the thickness of the glass slab. Then if you are going to consider this as a second identity, which this is the second equation I am going to get here. So AB is going to be T by cos R. So AB is going to be T by cos R. This, if you imagine, is equation number 1. This is going to be equation number 2. So substituting 2 in 1. So if you substitute 2 in 1, what are you going to get? So x is equal to, instead of AB, I am writing T by cos R. So if this is going to be T by cos R, this remaining part is sin I minus R. So I got this one. This is x is equal to T sin I minus R by cos R. This is an equation I'm going to get, and that is called as lateral shift, the concept of lateral shift. Once again, how much the light ray is shifted from its actual path is given by x here. So that x we got, that is x is equal to T sin I minus R by cos R. So you can just simplify this one. This can be written as T sin I cos R minus cos I sin R according to trigonometric formulas. So what is trigonometric formula actually? Sin A minus B is equal to sin A cos B minus cos A sin B. So once again, sin A minus B is equal to sin A cos B minus cos A sin B whole divided by cos R. So this is whole divided by cos R. So I can write like this here. You can take sin I separately. You write sin I like that. Cos R by cos R is going to be cancelled. So here only sin I is left. T is present here. And minus cos I, you can consider cos I as it is. Whereas sin I by cos R, if you divide partially, it is going to be tan R. So I am writing like this. Let us try to understand the problem here. So with this I have completed the concept of lateral shift. So what is lateral shift here? I have written the formula which I am going to mark with a red box. So this is a required formula. But according to the problem given to us, we have to just modify the formula like this. Then finally what are you going to get? The final step is, if the lateral shift produced per unit thickness is 1 by root 3, it is given like that. So if it is 1 by root 3, how to find out this? So once if you understand these basics, we can go for the next step here. I think if you write this one for some time, I can go to the problem, the next. So here, if you understand this concept, then I will rub it and go for an actual problem here. So what is an actual problem we are going to discuss? So the actual problem here is, I have to find out lateral shift x here. But the problem explained here is, he has given the ratio. The ratio is lateral shift per unit thickness. So lateral shift per unit thickness. What does it mean? It means that you have to write x by t. This is x comes down and t comes down here. So this is going to be x by t. So if it is x by t, the formula left there is sin I minus cos I tan R. So this is the formula which is left out. And according to the problem given over here, x by t can be taken as sin I. And what is sin I? Sin I is, the problem says that here I is going to be 45 degrees. I is going to be 45 degrees. So if I is going to be 45 degrees, you can write sin 45 minus again cos 45 tan r. Okay, so I have substituted the values of I and r. Then x by t is equal to sin 45 is 1 by root 2, cos 45 is also 1 by root 2, and this is tan r. So according to the problem given over here, he has said that lateral shift per unit thickness, that is x by t is already given to us, it is going to be 1 by root 3. So we doesn't have any work with this now. I am going to rub for an extra space required to write the problem over here. So therefore x by t is equal to 1 by root 2, 1 minus tan r, which is equal to 1 by root 3. There is no work with this now because the value of it is given. So therefore we can write this implies that 1 by root 2 into 1 minus tan r is equal to 1 by root 3. So therefore I'll write this one like this. 1 minus tan r is equal to, this root 2 goes here, you can write it as root 2 by 3. And I take tan r that side, this one here. So I can write 1 minus root of 2 by 3 is going to be equal to tan r. So the final step is, r can be considered as tan inverse of 1 minus root of 2 by 3. So this is a required answer. You can note down the answer. Okay, it's a very simple concept. It's very simple here. So lateral shift per unit thickness is nothing but x by t sin a minus, this is a left out identity after simplifying the problem. So I is going to be 45, I have written 45 here. So in sin 45, cos 45 having the same values here, I have written 1 by root 2 and 1 by root 2. And just after simplification, final step is this here. So it's a very simple problem. Thank you very much for listening to my class. Okay.